All right, first, did you get this? Yep. Okay. This is actually known as parent sequence. Why? I don't know. I mean, if you're famous enough, you can make up your own thing and people use your name. I saw this comic, and I had no idea like what that 302325 was. So, as with always, you Google it, Wikipedia. I found out that was the name of it. But, did you figure out the next term? This one. 3. The next term? 0. 5. So, the way this series sequence works is you add your two terms together, like Fibonacci's, but then you skip. Two terms together, skip. Two terms together, these two together give you 5. These two together would skip, and your next one would be 5.
That is weird.
What would be your next one?
7.
7, 10. So, like I said, why? I don't know. That guy invented it.
Cool beans, though.
So, why? I'm not sure. Kind of like a Google. Somebody invents it. If you're famous enough and you put a name to it, people will.
I'm gonna create a series.
So, but it's going to be easy for us. For most of us, nobody really cares what we think. So if we come up with something, it won't become famous. So. All right.
Sequence.
So we talked about this last week, and we showed these slides. I didn't have notes. If you want to kind of fill these in now, you can. We talked about the difference between a finite and an infinite sequence. And as you can see here, there's the two of them. Finite just means it stops. You can count how many terms there are. Now, there may be a lot. Right? I mean, you could have infinite, you could have millions of terms, but it stops. And infinite goes forever. If we expand here our sequence, we now have what we call a series. And a series is just the sum of all of our terms in our sequence. So, our formulas for arithmetic and geometric sequences here, we're going to continue to use. These aren't going away because these still give us the terms of our series. So if we have a series and we say expand the series, what we're going to do is write out all the terms with a plus. If we're asked to evaluate a series, you want to determine what all those terms sum up to, what they add up to. So, if we have a arithmetic series, here is our formula. Now, I'm not going to write this formula down. Take this formula, and a sub n is equal to this right here, right? Everybody see what I did there? I took a sub n. And so now, if you want to write down a formula, write down that formula. That is like a simplified, easier to use formula that we want to look at. Okay? So, once again, you are not going to have to remember this. I'm going to write it up here. So let's look at that formula. So let's say we have this series, 2, 5, 8, 11, 14, 17. Arithmetic, what's our difference? 3. We're adding 3. So if we want to look at the sum of the first 6 terms, okay? So these here are the first 6 terms. Now, if it's just those 6, I can just say 2 plus 5 plus 8 plus 11 plus 14 plus 17, and I would just get 57. if you actually just wrote them out, so I want you to see. If we do S6, that is the sum, that n is the sum of the first 6 terms. Now let's use our formula. Our formula n is 6. 2 times our first term is 2. Plus 6 minus 1, what's my difference? 3. All over 2. So that is going to be 4, 15. So we have 6, 4 plus 15. Divide by 2. And we get 57, which is the same thing we got. Okay? All right. You try 20. Same problem, but do S of 20. You try to write it, put it in the formula. You have a calculator. Do you want there's some on the table over there? Your calculator?
Yeah.
Can we get an answer? 610?
Yeah,
610.
seems like much.
Seems like much?
That's 14.
You wanna write it all out and figure it out?
Right, you could you know, if you took your calculator, you could just take 2 plus 3. Right, if we did 2 plus 3, you get that?
Uh-huh.
And then we'd have to do what? Plus 3, give us 8, plus, I don't know if you have to figure it out, yeah. You have to write them out, no easy way of doing that quickly. So, all right. But could you do 2 plus 5, 2 plus 5 plus 8 plus 11 plus, you just keep doing it over and over again? Yeah, you eventually get there. I promise you at some point, like on a quiz or something over these, I will ask you to sum up the first, like, 1,000 terms to force you to use the formula. Because if I ask you to find the first 1,000, you're not going to hit, plus 3, plus 3, plus 3, plus 3, plus 3, plus 3, plus 3 in the calculator. Leslie's looking at me like, that's a challenge. You challenge, like, I can't do the first 1,000. So, that is the sum of the first n terms of an arithmetic. Now, let's look at geometric. Okay? And let's write this. So there is a formula for the sum of the first n terms of an arithmetic. I'm pretty sure this is a formula you used with Patrick. So, let's say we have this series. 1/2 plus 1/4 plus 1/8 plus 1/16 plus ... And we want to find the sum of the first 30 terms. So for our formula, the first term is 1/2. 1 minus, what's my r here? What do you multiply by to get the next term? You multiply by 2?
Well, it's
So you are not multiplying by 2, you're actually dividing by 2, which would be the same as multiplying by 1/2. So my R is 1/2. Now, let me give you a hint on how to type this in the calculator. When I do this in the calculator, the way I'm going to type this in is I am going to type that part right there in first. I'm going to go 1 minus 1/2 to the 30th. Because if you try typing this in, there is like so many parentheses everywhere. People always mess this up.
We messed up the last one.
They messed up the last one. This one's even
I
harder.
got like 137. I was like, how did you
So
guys do
I like to type this part in. Then I will come back and I'll multiply by the 0.5 on the top. And then I'll divide by the bottom, which once again, make sure you do parentheses. Let me get that. Which is 1, 2, 3, 4, 5, 6, 7, 8, 9. So this is 1, 2, 3, 4, 5, 6, 7, 8, 9.
You'll make us turn that into a fraction.
The part doesn't even turn into a fraction, does it?
I don't think
I
so.
don't even know. Nope. This is a decimal. And if you remember, we looked at this one before, and if we said, we said if you add all those up forever, it equals 1. So you can kind of see 30 terms don't add up to 1, they add up to 0.99999999991.
That's funny.
So let's talk a little bit about infinite series here today. So infinite series is what happens if we want to add up all. So let's consider a few numbers, okay? And these are not on your notes here to start, but if I wanted to, if you got a calculator there, take 1/2 to the 10th. And see what you get.
9.765625 B.
You get that, right?
Yeah.
No, you got -4 because it's scientific notation. I wrote it last time, okay? So try the 30th.
9.3132257
Yeah.
You got that?
Yes.
So if you think about these terms, consider to the 100. Try the 100.
I don't even want to. 7. 31. It's smaller. Oh.
You got that, right?
Yeah.
Yeah.
Now, if you take 1/2 to a power, will it ever be 0? Try 1/2 to 1,000.
It's here.
Well,
It's too small.
It's too tiny.
your calculator just gave up, right?
Yeah.
Yeah.
Yeah. What is it actually?
What's
What's that?
That.
Oh my god.
9.33 times 10 to the negative 302. I wonder if that was
It doesn't look like that big of a number.
It's not a very big number. It's a really small number, actually.
Oh.
Got him.
There's actually 300 and some zeros there. So the point is that as you take 1/2 to higher and higher powers, the numbers get really, really, really small. So when you look at a infinite series, and when we specifically look at this infinite series, 1/2 plus 1/4 plus 1/8 plus 1/16. Think about for a second, based on our formula over there, what's the formula for the nth term? So it's the first term. What's my r? 1/2 to the n minus 1, right? Now, if we simplify our exponents, the terms are just 1/2 to the n. Because this is just
2 squared, 2 cubed, 2 to the fourth.
so this is just our terms. So what we've been looking at is that's the 10th term of this series. That's the 30th term. That's the 100th term. That's the 1000th term. So what happens when I add up all infinite terms? How does it go to 1? Well, what keeps happening to these terms as we go further and further and further? They keep getting bigger and bigger and bigger, right? From Bryce's definition, which means there's more and more zeros there, right? That's getting longer. So what happens if we want to find our formula? What's the sum of the first n terms? Well, we use our formula we just looked at. It would be 1/2, 1 minus 1/2 to the n, all over 1 minus 1/2. But notice something here. Look at the bottom. What is 1 minus 1/2? 1/2. So wouldn't these 1/2s cancel? And 1 minus 1/2 to the n. So notice that for a second. Let's look what we end up with.
The mess.
Yeah, I'm not going to talk about that. That's a limit. So we have our sum is 1 minus 1/2 to the n. So if s is 2, if I want the sum of the first two terms, now look over here. What's 1/2 plus 1/4? 3/4, 0.75, right? So put 2 in here. This is 1 minus, what's 1/2 squared? 1/4, 0.25. 1 minus that, this is 3/4 or 0.75.
One.
If I want to find s sub 3, that's 1 minus that, which is 1 minus 1/8, which is 7/8. Now, if you add up what's 1/2 plus 1/4 plus 1/8, 7/8. So this is the formula. Now, what happens if we want to find the sum of the first 1,000 terms?
Give up.
It would be 1 minus that. And what is 1/2 to the 1,000?
0.
It's not 0.
It's 1.
Oh, 1.
It's 1 minus that number.
Yeah.
So it's not exactly 1, but
It's close enough.
it's pretty close, isn't it?
What's this one?
Well, yeah, our calculator gives up and just says, I check out, taps out, and says it's done. Because the calculator looks at this and says, that's basically 0, so that's 1. So what we're going to end up with here is if we have an infinite series, this part of our formula right here basically goes to 0. Because this number here gets so small. It goes to 0. So what we end up with is our last formula. Our formula for the sum of an infinite series. And you also did this, you did this one. Look back. All right, homework, we're going to continue with these infinite series tomorrow. So homework here, and have you cross some of them out. Because of time, I'm skipping some of these. Skip 6. Skip 7. And 8. You can do 9 and 10.
Well, this is everything come back. Those are actually
No. This would be due when we do the test. So, due Friday. We're going to continue with this infinite series. Now, the one thing I want you to notice here is it depends on R. Because if our R is greater than 1, things blow up. Because think about, just like 1/2 to the 100 gets really, really small. What would happen if I took 3/2 to the 100? Because it's bigger than 1, so when you multiply it, it keeps getting bigger and bigger and bigger, and it gets gigantic. So it all depends on 1. If your R is less than 1, you can then have an infinite series that you can sum up. Okay? If it is greater than 1, you can't. We'll continue with this tomorrow. And then also tomorrow we're going to look at sigma notation. Yay. You remember that from last year? You did that now.
No.
I certainly do.